Hello, everyone. Welcome to Hoot number 49. I'm just waiting to see if I am indeed live or not, just so I'm not talking into empty space. All right, I am live. Perfect. Uh, Welcome to Hoot 49. My name is Peter, and today we'll be talking about configuring and how to configure external services with Istio's ServiceEntry resource. So we'll talk about what ServiceEntry is, and I'll show you how to add additional entries or how to use this resource to add additional entries to Istio's internal service registry. This is useful when you want to bring services that are outside of your mesh and make them uh, part of your mesh, as well as when you want to add services to the mesh that are not necessarily managed by Kubernetes, for example, for VMs. All right, let me figure out how to share my screen, and we'll get started. All right, there you go. Perfect. So it'll be mostly demos today. I don't have any slides. During the stream, feel free to ask any questions, and I'll glance down and left across all my monitors to see if there are any comments or anything. All right, so what do we have? I have a Kubernetes cluster up and running. I have Istio installed already with East-West Gateway, because if we have time, I'll show you the VM workloads as well briefly. I have Prometheus, Grafana, Kiali as well, and in the default namespace, I already have a sleep workload, and this is what we'll use to send requests from, just to test everything out. I don't have any other resources, Istio resources deployed, so everything is empty. The one thing that I did do is, and well, I guess this is the default setting anyway. So if we look at the Istio operator, my outbound traffic policy mode is set to allow any, and this is the default setting. We'll switch it to registry only later on. So what this outbound traffic policy does is it defines how sidecars in the mesh handle external services, basically services that are not part of the internal service registry. The default setting is allow any, and this basically allows the sidecars to send requests to any unknown external services. So the other setting is called registry only, and when this is set, the Istio sidecars will block requests to all external services that are not part of the internal service registry. So when the allow any setting is set, if we look at the configuration, so I'll do Istio CTL proxy config clusters. For my deploy, sleep, fully qualified name, pass through cluster, and we'll do a YAML here. Oh, typo there. There we go. All right. So what is this pass through cluster? Like if you've ever seen this, this is, since allow any is default setting, you've probably seen it in that context. So the pass through cluster, if we look at the configuration down here, is of type original destination. So an Envoy original destination is a special type of a cluster where the requests just get proxied to the destination IP. Now, typically, the other types of clusters in Envoy have endpoints set. However, in the original DST type, there's no endpoints because the destination is the actual location where the request was sent to. So let's look at the full config. So the thing is, when we make requests to a cluster or to an external service, I'll be making requests to HTTP bin, something that's outside. The request was just going to get passed to the original destination. So let's look at the Istio proxy all deploy sleep JSON, and we'll just do all .json. Proxy config all will just give me the full configuration. So if we look at here, let's scroll this down. And if we search for, let's do pass through cluster, and we'll do it this way. So you'll notice that this is the cluster that we've seen before as well. However, if we look at the filter chains and filters, we'll see that this pass-through filter chain is set as a default filter chain. So what does that mean? So every request in Envoy will go through a set of filters, but even before that, there could be a filter chain matchers or filter chain selections, basically a set of things that can select different filter chains, right? So you can say, oh, if I'm getting a TLS connection, then select this filter chain, versus if it's plain text, go to that one. And there's also the concept of the default filter chain, which in case if neither of those two match, the default filter chain will get executed or selected. And in the default installation, where allow any is set on the outbound traffic policy mode, right? This default filter chain contains this pass-through cluster, which is a type of original destination, which just means let the requests go through to the original destination. So let me also do, so if we send a couple of requests, let's do that. HTTP ban org headers. Right, so we get back, I'm just sending a request from that sleep pod that we deployed to http-bin.org/headers. For some reason, it's extremely slow. So, and what I'll do is since I have Kiali installed, let me do port forward to non-Grafana. We'll do Kiali, and the port is this one. So now let me open. So go to localhost. I'll share it right away. I open Kiali, and then let me stop this share and then present this other one. Share screen, Kiali. All right. So we have Kiali here. If I go to the graph, you'll notice that all the requests that I sent from the sleep pod are going to this cluster. It's called pass-through cluster, right? Even though we send the request to http-bin.org, it's called the pass-through cluster because that's the name of the cluster for all external services. So let me go back to code. There's window, this one. Okay. All right. So now if we would go and change the traffic policy. So what I'm going to do now is I'm just going to find the Istio operator, and I'll show you the Istio operator that I use to install Istio. This is how it looked like, default one. I'm using the demo profile. I'm setting the outbound traffic policy, and I have a couple of values here that are for specifically for VMs. So what I'll do is I'll change this allow any to registry only. And then what we're going to do is I'll reinstall Istio, and we'll say Istio CTL install -y -f this. Paste this in. And this will reinstall Istio by setting the outbound traffic policy to registry only. All right, so this was installed. So now what happens if I send the request now to http-bin.org? So notice that I get 502 bad gateway. So the requests are not going through anymore. So if we look at the configuration again, so I'm just going to do all deploy Istio CTL, get it again. And we'll go here. This time, if we, there's a concept of a black hole cluster. And if we find the actual cluster, there you go. So this is the actual cluster. You'll notice that the type is static. However, typically when you define clusters in Envoy, those clusters typically are either original DST, right? They have a type, or they have a type. There's a cluster with the associated list of endpoints as well, right? Basically, here's my cluster, and here's all the different IP addresses, right, where my service or my endpoints actually are. Now, notice we have the type of static here. It's a black hole cluster. However, there's no endpoints here, right? Because we want the connections to be dropped. Similarly, if we would look for default filter chain, we'll notice that the default filter chain will be set to, let me see, black hole cluster. So the default filter chain now is set to the black hole cluster. And if we send a couple of more requests, then I'll just switch to Kiali really quickly, and we'll see that there as well. If I refresh, there you go. So you'll notice that this time it goes from sleep to this black hole cluster, which is basically Envoy slash Istio are saying, no, I don't know about this external service, so just drop all the requests that are sent to any destination that's not inside my service registry. Now, note that this is not a security boundary, right? This is just Envoy proxy doesn't know about that, and it's just not going to send a request there, right? However, if I'm inside not a proxy but a different bot, I can still reach everything like external services out there. So this is a recommended way that you should go about, right? Set your traffic outbound policy to registry only, because that will give you the control over what services are allowed in the mesh, or even what services are allowed to call, or which services are your workloads in the mesh allowed to call out to. So how do we make or tell Istio that, hey, this HTTP bin service, external service, we want to make it part of mesh. This is something that we want to have or be able to access. But the way to do that is with a resource called ServiceEntry. So if we deploy this, and I'll go and explain it after I deployed it. Don't ask me again, and let's deploy this one. So we've created this ServiceEntry, and we can look at it. With a specific host, the location that specifies what the location of this service is. It's external to the mesh. There's also mesh internal location. I'll explain the differences soon. And the resolution is DNS, because we are providing an actual host name, and we're telling Envoy, hey, go resolve this host, and then just send a request there. So if we would look at the configuration this time, go to all. This time we can see that there's a cluster that was created called Outbound port 80. There's nothing here because this is reserved for the subset name if we had one, and then the name of the DNS name, right? The name of the service that we're trying to reach. Let's actually look at the cluster as well. This was in the route. So this is the cluster. It's a strict DNS. And there's a load assignment here and the endpoints. This is what was missing in that black hole cluster there. And there's the address. That's HTTP bin and port That's port 80. So what ServiceEntry basically does is it adds and configures a cluster in Envoy configuration. So if we would send a couple of requests now, let's send a couple of requests. Now it works again, right? Because Envoy / Istio, they know about this external service, and there's a configure route and a configure cluster where the requests are gonna go to. Similarly, if we look at Kiali, let me refresh here. This time we actually see the name, right? So this time we see that there's an HTTP bin. Sleep was calling out to HTTP bin. It's not saying pass-through cluster. It's not saying black hole cluster anymore. It actually picks up the name of this external service. Let's go back to this one. All right, so let's look at the ServiceEntry resource a bit closer and explain the different values that we have here, right? So I mentioned location already. So this field specifies whether the service is external to the mesh, and it's typically used. The mesh external setting is typically used for external services that are consumed through the API. Or if you're going to set it to mesh internal, it's typically you're going to set it to mesh internal when you're using it for services that are running on VMs, for example, and you want to make those VMs part of the mesh. Now, the difference between the two is in how the mutual TLS authentication and policy enforcement works, right? So with mesh external services, the mutual TLS authentication is disabled. So if you want to enable it, you'll have to do it manually with the destination rule. And also the policy enforcement is going to be performed on the client side, caller side proxy instead of the server side, right? Which kind of makes sense because external services, I don't know, like for with a high probability, I can say that HTTP bin org does not have a proxy or Envoy proxy running on the other side, at least not an Envoy proxy that has like a shared secrets with my cluster or with my caller, right? Now, if this is set, if the location is set to mesh internal, right? Then we're kind of telling that, hey, we know that the server on the other side is going to be Envoy, right? MTLS is going to be turned on, and policy enforcement can be done on the server side proxy, because typically in the VM workload scenario, you're going to run Istio proxy or Envoy proxy on the VM. We also have the resolution field, right? We've set it to DNS because we want to resolve, in this case, the IP address of httpbin.org by querying the DNS. The other options that you have here for DNS are none, right? And this is for any connections that have already been resolved and you don't have to do any resolution. You can set it to static. This is going to tell the proxy just to use the IP addresses that we can specify in yet another field in this resource. And then there's also DNS round robin, which is going to resolve the IP addresses by querying the DNS asynchronously. So it will use the first IP address that's returned without relying on a complete DNS resolution. So now that we have, where did my term? There it is. Now that we have ServiceEntry defined, we brought the HTTP bin org service inside our cluster, made it part of our mesh. The nice thing that we can do now is, for example, we can define a virtual service, and we can say, we can target that host, and we can say, hey, just inject an abort for 100% of the request and just return HTTP 400, right? So basically what we're doing here is we can have these external services behave or use the same features as if they were internal to the mesh, right? So once I apply that, if I send a request, you'll notice that I get back a 400, and it's going to say it's a fault filter abort because it was the virtual service that did this. So let me delete this. So this is the same way that you would do it for any services that you have running inside your cluster, right? You would target that, you would apply setting virtual service to that host, and then define the routes and all the different settings as well. All right, so I'll delete this. So this is if I have a domain name or a host name, right? So let's say what happens if I have, I just delete this. If I have an IP address instead, right? So I don't have HTTP bin org, however, I have an IP address. So let's get an IP address, and let's pick this one. So how could I configure this service entry if I only had an IP address, right? So this is how you would do it. Notice the host is set to something.blah because in this case, it doesn't really matter, right? We're setting the actual address in the endpoints field. So this is the actual IP address. We're setting the resolution to static because we are providing the endpoints. Mesh external is the same, but also notice that we've set the addresses field here. And this addresses field, what we're setting here is a virtual IP, right? So we're basically saying, hey, we're adding this HTTP bin service entry to our mesh. It has this endpoint, and we want it to be accessible or reachable by this virtual IP. So let's apply this one. This has been configured. Now, if we send a request to http bin.org, this should fail, right? And this is failing because we have registry only, of course. However, if we use virtual IP that we came up with, this time it should work. And as you see, it did work. Notice the decorator operation header is set to something.blah. So this is the value that Envoy still uses internally. However, the host was set to 10.0.0.0.0, right? So this is the virtual IP we set. Now, this is all right, right? And there are cases where you would want to do this, right? However, let's say you wanted to use an actual host name. So you have an IP, but you want to use a internal host name or some host name, a fixed name that you want, fixed and unique and unchangeable name that you want to refer to instead of a IP address. So the way that you could solve this is you could create a headless service, so headless Kubernetes service. So if we do it this way, right? Show you. I'm not going to apply this. I just want to show you how it looks like, right? So this is pure Kubernetes here. There's no Istio involvement per se, right? So we're just saying we're creating a Kubernetes service with this name, setting the cluster IP to none because we want to provide the endpoint, right? We're setting the port for the service and then the target port for the endpoint. And then we specify the endpoint itself, which has the IP address. And this is that IP address that we got. And a host, and this is just the naming that you have to follow when you're doing this. So if I would create this, then I'll be able to use my HTTP bin SVC, right, to access this endpoint. I wouldn't need a service entry anymore, right? Because Istio will treat this service as part of the service mesh since it is a Kubernetes service. The cluster that's going to get created if we would deploy this in Envoy is going to be the original destination type, right? And it's going to be to the actual IP address that this endpoint is pointing to. Now, the downside of this approach is that the outbound traffic policy that we have, right, the registry only policy that we define is not going to be respected, right, because the service is going to be considered as part of the mesh, even though the IP is external, right? So we're accessing it outside. So Istio doesn't really know that this service is pointing to an external IP, right? And as I mentioned, the outbound security policy isn't outbound traffic policy isn't a security thing, and you shouldn't be using and treating it like that, right? Um, Now, luckily for us, Kubernetes has a concept of external name service. So let's see how that looks like. If we do this, right, then Istio is going to treat this external name service as an external service, right? So the outbound policy will apply. So if we deploy this, right, so it was created. And then if we update the service entry, so it's going to be me. I'm just going to paste it here. For this external, let me actually delete what we have so they don't clash. Well, actually, they shouldn't clash. Doesn't matter, right? Whoops. So host is this one, right? Because this is what we've named the Kubernetes service. It's mesh external. We want to do DNS resolution. So let's deploy this. Now, if I send the requests, if we do external HTTP bin headers, we should get back a response as well. There you go. So this is how you would do the, I have an external service. You could create like an external Kubernetes service, define it there, and then create a service entry, which is very similar to what we had before, but without the external names. So for example, if I wanted to use external HTTP bin hostname instead of httpbin.org, this is how you would do it, right? You are basically abstracting out the actual name with the internal name that you wanted to use, and you do it this way, right? So this can be whatever you want, right? So another thing that typically comes out is how to originate TLS from the proxy, right? So for example, internally, let's say, I want to use HTTP bin to connect to my external service, but then from that client-side proxy, I want to upgrade the connection to HTTPS. How can I do that, right? So ServiceEntry is involved again, and I'll use the example that they have on Istio's website. Let me just delete these service entries. Okay, so we don't have anything. And then I'll take the example from Istio's website. That's right. So they're defining a service entry for edition.cnn.com. And what we're doing here is we're defining two ports, right? We're defining port 80 and we're defining port 443. So let's deploy this. Okay, so this was created. Now, if we send a request, going to be a lot of text here. So what are you going to notice here that we sent the request, I go up here, to HTTP bin, right? And we got back to 301. That's why we have the -L here to follow redirects. And then proxy transparently made another request, right? So it redirected from 80 to 443, and another request was issued to HTTPS, right? So curl is smart enough to handle these redirections. However, this means that we have a redundant request that's going to double the latency, right? Because we're not just making one request. Curl is making one request and then making another one. So what we could do is we could create a destination rule that says, hey, if there's a request that's being sent, so let me just show and then I'll explain, right? So a destination rule for edition.cnn.com. So on the port 80, right, if there's a request to port 80, we want to set the TLS mode to simple, which is basically telling the proxy to start a TLS connection, right? And then in addition to this one, so let me deploy this destination rule. Okay, deployed. If we also need to modify the service entry a bit, and it's a subtle change, but it's not going to work if you don't do it, right? So target port 443, right? So what we're saying here, whenever it goes to port 80, go to 443, right? It's going to go to 443. So if we deploy this as well, just to update it, we have the destination rule already. There we go. So we've configured it. So if I resend the request to HTTP again, right? There you go. You'll notice that the request went to, there was just one request that was made, right? So, and we got HTTP back, right? It was HTTP. However, then the proxy upgraded the connection to TLS, originated the TLS from the sleep pod, right? Istio proxy, and then did that transparently for us. So what this does, it allows you to use HTTP, right? Port 80, whatever, inside, right? So all your services, even when they're calling outside services outside, would use 80, but then whenever they would call outside, we would use the destination rule to do the TLS origination. All right, so what else is there, right? So there's, in terms of external, like when talking about external workloads, external services, there's also the concept of workload entries, right? So what is a workload entry? So workload entry allows us to explain or describe properties of a single workload, right? So it's a companion to the service entry, and it allows us to select the workloads through the label. So this is how it would look like, right? It has the concept. It's used for VM workloads mostly, right? Or services or mesh internal services, right? There's a concept of service accounts, right? And there's an address as well as the labels, right? So we can set the labels, and then we could have a service entry, for example. Let me show you. HTTP bench service for this host. Now, notice the mesh internal. And then instead of having any endpoints or addresses defined, we have this workload selector that's basically saying, hey, whenever there's a request sent to, that's how I read it, right? Sent to http bin.hello world on port 80, the target port is going to be 8000. And then also the backing instances, right, for this service, you can select them with this workload selector, right? And this workload selector, you'll notice this is one of the workload entries that gets selected by this, and it's telling Envoy that, hey, this is an instance of a internal service. It has this service account. It uses this service account, so you can do auth, right? And it uses this address, which in our case is the VM address where Envoy Istio sidecar, Envoy sidecar or Istio sidecar is actually installed and running, and it's listening. All right, so let's do the VM example. And I already have the VM running. I'm not going to go through the whole like installation process because it's not a lot of work, but it's just a lot of commands, right? We've already done the installation portion, right? With these two settings. I'm also setting the mesh ID, the cluster name, and the network, and then these two environment variables. And then the other things that you'll have to do is I've already installed the east-west gateway. So east-west gateway is something that's used to talk to a VM. So all the requests are going to go through this. And I think I've also have virtual service there. Yes. So let's just see this one. Doing so it applies to the Istio gateway, matches on this port, and then just redirects to Istio. So this allows us to, any calls that are made from the outside, right, from the VM, will go to the Istio basically. So the external workloads can connect to Istio and get its configuration. We've also deployed a workload group. So workload group is another concept. Let me show you this. It's another concept that's used in these scenarios. And what this one is doing is basically, you can think of in a way, you can think of workload group as a Kubernetes deployment, and then workload entries as individual pods, right? So with the workload group, we define a template we want to use for the workload entries, right? And because we set enable workload entry auto registration to true, as soon as I've set up my VM, I've copied the trust over the certificates and launched the Envoy proxy there, the workload entry, let me move it up. The workload entry called VM-app, that's the name of my app, right? And it has the IP address of the VM setup, right? So this was all created automatically for me, right? So it's saying that it was created from a workload group. It has this address, it has these labels, and it uses that specific workload service account, sorry, right? And then let me go to my VM. I don't need this anymore, so I'll just SSH into the VM. If I don't know if I have anything running here, but we can look. We'll just run a simple Python server and nothing else. So just running it on port 80. That's the only thing that we're going to do. We'll consider that as our workload, right? The other thing that I did is let me see what the name of the VM namespace. If I get the services in the VM namespace, created this VM service, right? So I need a service, a stable name that I can use to access the VM workload, right? So let's see how this looks like. Nothing special here. It's port 80, target port 80, and there's a selector for app, VM app, which is the actual, whatever my workload entry was defined as well, right? So what can I do now? Now I can run curl to this VM service in this VM namespace. And if I do that, I should get back a response. So this is a response that's coming from, if I switch to my VM, right, you'll see this entry here. It's coming from my my VM. Now, the fact that we have labels there, right? There's a label, workload label selector, right? That means that we could also deploy a workload in our cluster with the same labels, right? And I have one here. It's called cluster app, right? I'm not really good at naming things. And this workload has the same label, right? It has app VM, VM app set, and that's the same. That is the same. Whoops. That is the same label that this workload entry is selecting, right? So if I send a request a couple of more times, this is coming from the VM. You'll notice that this time I got a different response, right? And this one was coming from that cluster app that's running inside my cluster. So what I'm trying to say here is that even if you have VM workloads outside of your cluster, you can still deploy and or run workloads in your cluster and then load balance between the two or three or five or how many you have, right? And what this means is what you can do is, let's say you want to bring your VM, you want to migrate your VM workloads to your cluster at some point. You can start by bringing the VM in first, and then as you either migrate portion of the workload or a workload already, you can run it in your cluster and then have them load balance between the two, right? You can set the traffic routing, weights, percentages, all those things that you want. and slowly phase out, let's say if you want to do that, phase out your VM workloads and have them run inside the cluster. Right? So it just gives you the options to do that. All right, so looking, there's no questions, so I'm assuming everything is perfectly clear, and I think we're right on time, more or less. Hopefully this was useful. Leave a comment if you have any questions, and I'll also update our Hoot GitHub repo with this example, this demo, so you can run it on your own in your own cluster. All right, thanks everyone, and I'll see you next time.